Hello everyone, we are Team 2 and my name is Paul. Today we are going to present our report about Mango image recognition, and this is the 4 methods we use in the model to implement. This is our outline. At first, we are going to introduce our methodology. At the left-hand side, this is our flowchart. At first, at the top, we can see that we input our original image and then transfer it into a Mango image. And this Mango image will let us augment our image to a more amount. And then the below is that we have 3 data paths. The leftmost data path is that we will produce a defected area of the Mango. In the middle one, we directly input the Mango image to the ResNet. And the right-hand side, we can see that we input it in a so-called LAB model. And this model will produce a color feature and to increase weight of the back color.
Hello, I'm Jeff. And initially, we use the original images to train and select 3 features, which are A-mean, A-variance, defects area to classify Mango. And the initial fail loss is 1.5 and the initial fail accuracy is 0.5. And secondly, we use ResNet UNet for background removal and Mango classification. And thirdly, we add more training image and epoch. And finally, we use data augmentation plus UNet plus ResNet plus TAGIBoost for feature and sample. And you can see the fail loss become gradually lower and the fail accuracy become more and more high. Although fail accuracy and the fail loss are still escalating, it still can upfill the trend, and you can see the trend become more and more stable.
Hello, I'm John. In the next, I want to discuss our model detail. First, we do the data preprocessing by using the data augmentation. As you can see, there is some rotation and resizing and translate in the image. The data augmentation can make the data more various. And second, we want to identify the Mango areas. So we decide to use the semi-supervised learning, and we label out the Mango by hand and put the image to the UNet to find out the Mango area, and this is the result. And there are some noise on the label because of the background might cause this problem. So we try to fix out the problems by find the largest contours because the largest contour is usually the Mango areas, and then we fit the areas in an ellipse to circle out the Mango. And we use ResNet as our main model, and I want to briefly introduce the structure of the ResNet. And ResNet processes the image to the convolution layer and the subsampling layers. And after the convolution, it concatenates the data into the flattened layer and fully connected network. And the trick of the residual ResNet is it uses the residual learning to make the process more effectively and use the dropout layer to make the learning result more robust.
Hi, 我是郭子豪. Let me talk about defective area. First, we use LabelMe to label Mango defective area and put data into SSL and UNet model for detecting Mango defective area. The result is like this. And second, talk about color space transform. For colors difference, we translate RGB to LAB for easier to observe because the two ends of a value are green and red. After that, we draw mean of A value and covariance of LAB to observe. We can see that the trend of class C is bottom left, and class A is the trend of top right. We choose a value below 150 as one of features, because the value above 150 will affect our misjudgment of the local judgment of Mongo, like the top left and top right Mongos. One peak is as 150, is this, and one is as 70, like this. Because the Mongo on the top left has dark point, is this. Looking at the picture below, you can find that the green Mongo has a larger area than top, so we choose covariance and this area value being sum of feature to train.
Hi, I'm Yiping. In this project, we found there are 4 points where active the color space's performance directly. Then we discussion about this. The first one is color space. The traditional RGB color space cannot celebrate the distribution of the red and green. So, color space transfer is very useful to classify the colors of the image. Like this time, we change to RGB to LAB color space. The second is a color judgment. The color distribution of the B and C is overlapped to hide, resulting in greenish. Mango will be charged to C, but the answer is B. So, the weight of the color influence should be reduced. The third is about the background noise. Complicated backgrounds will cause inefficiencies in machine learning. Therefore, finding the location of the mango and use image mappings to remove the background noise will activities improve the accuracy of the model. The fourth point is the shadow. The mango's shadow and the water drops, those are very easy to misjudge as a defect. May use CV2 errors to reduce the mapping area to lessen the effect of the mango shadows. Finally, let us make a conclusion. Data accumulation and ensemble the features could effectively improve the accuracy. According to V.C. Larry and practical experience, the amount of the data required is probably equally to 10 multiplied by dimension. In this case, we only get the 5,600 dataset, much smaller than NEAT. Layer loss, reducing the dimension of the image and increasing the dataset will be the necessary and important. In order to remove background noise, we tried many methods. The test results show that about the removing background noise and finding defective area. Using semi-supervisor learning SLL at UNet is superior to K-means algorithm and some OpenCV packages. EDA and the data processing play important role in the classification task. When judging ABC grade, the main thing is that the machine learn to. When judging ABC grade, the main thing is to let the machine learn to identify defect and the bad point, not to emphasize how good it is. Using EDA to correct action between the data, find out important variables, and check if the data meet our assumption of it as a reference or subjudgment for the future analysis.